Hi, everybody. My name is Amber Forty. I am a technical manager at BCI, and I am so happy to be here with you all today. I am going to present you all a demo that one of our lead instructors, Jeremy Blackthorn, put together. And it's so cool. And once the demo's over and you've seen the training and you're excited and you just want to know more and more, we actually have a free 5-day class in our booth that you can sign up and register. It'll have the syllabus, the dates, the description. And this is our way at BCI to show how we support closing the gender gap with women in cybersecurity. So I'm going to share my screen and show you the demo, and I will be back with you shortly.
What I'm going to do now is, hi everybody, my name is Jeremy Blackthorn. I don't got my face up, but I'm just going to assist Amber here in demoing some of our environment. So what you see on the screen is this is our custom virtual machine that we deploy for our classes. It's got all sorts of tools and streamlined and everything's working the way it's supposed to. So we're going to start here. We're going to go to the upper left-hand corner. We got class home, arcade machine. And this is going to take us to a Jupyter Notebook. So Jupyter Notebook, for anyone who's never heard of those before, the most closely I can really understand it is it reminds me of like MATLAB, where it has like these different cells, and each one of these cells can be executed. And I'm using a notebook here that Amber put together a while ago, and I think this is just perfect. So let me show you a little bit about what a Jupyter Notebook can do. So we don't really focus on Jupyter Notebooks in terms of like teaching, but we do use them in our teaching. So, and I'll show you why right now. And so the first thing here, this top cell, these are all different cells. The first cell here is in HTML, and you can execute that. And then you can have other cells, and they can execute things like Python. You probably saw that Python there. So hello, day of security, like that. And then any Python you could do, it does it too. So here's some of my bad Python. There we go. And then in addition to Python, it can also do things like shell commands. So if I want to do like list processes, like that. If I want to do, what directory am I in, things like that. And the idea is, at the end of the training, and let me show you, I'll open the table of contents here. So here's like sort of the whole notebook together. At the end of the training, after you've done the exercises and you've collected your code and your commands and things like that, you could also take all this and then you could export it as a PDF. So as the person taking the training, you get the virtual machine and you get the Jupyter Notebook. It's all local, so you get to keep it. It's not like hosted remotely and you have to access it. You get to keep it all on your computer. But for like maybe you want to take all of your expertise or experience and you want to export it to a PDF, and then you can take that PDF with you, give it to other colleagues or other fellow students, and then they can use that as a reference. So we switched to Jupyter Notebooks quite a while ago because we found it was just so much more fun and interactive, as opposed to like writing in the margins of like a printed out PowerPoint. I don't know if anyone else has ever had to do that, but I didn't enjoy that. So a long time ago, we switched to this. So, okay, so that's just a little bit about Jupyter Notebooks. But now let me tell you about the topics that we teach. And a couple of the topics that I'm going to talk about today is reverse engineering and exploitation. So let's execute a couple of these setup cells like that. And just like set some variables in the background, things like that. Now, before we get into reverse engineering, I'm going to talk to you about forward engineering, which most people don't call it that. They just call it programming. But when you spend so much time reverse engineering, you end up referring to regular programming as forward engineering. So this is probably where most of you have some experience. And here is a cell that just has a basic C file in it. It says hello day of security, like that. And so I can write that file to disk, and then I can run a command here, and that will display the file. And then if you change this here, and it writes it to disk, and then the file has changed. And that's just the cat command showing you what's in the file. Now, after we have written this file, and this is probably where a lot of you have experience, then you're going to compile it. And I'm just using a command here, GCC. And so we compile it, and then finally we execute it. And the thing that we really like about this when teaching is that you could do really quick iterations. So if you wanted to just do something like this, the difference between editing the file, verifying the file, compiling it, and then running it is just a couple of enter keys. And that just makes it a lot more convenient for like experimentation. So anyways, now that we've sort of grounded ourselves in like, here is how Jupyter works, and here's an example of a program, now what we're going to talk about is reverse engineering. Reverse engineering is going the opposite way. So instead of starting with a written program or writing a program and then making it into a binary or executable, we're actually going to go the other way. We're going to start with an executable, and we're going to try to go backwards and understand the logic all the way back up to the original design, the source code. So let's take a look at an example of that. And here's our first exercise, reverse engineering 1. So our goal here is to get the password, and the lesson for this exercise is going to be a couple of commands, and they're highlighted here. So manual page ASCII or man ASCII, file hexadecimal strings. And so let's execute the setup here. And this just tells us the directory that we're going to currently be in. So let me copy this. And now I'm going to open up a terminal over here. And we got this like, I don't even remember where this came from, but somebody was messing around and they started putting emojis in our terminals, and they just sort of stuck. So we left them in there. But let me transfer this directory. Okay. And what we have in the directory is the challenge. That's the executable. And our goal here is to get the password. So let me try to run this like that. Okay, it says enter password, and I just type whatever, and it says no. It's like rude. No. Okay, how about try again or something? So anyways, it says enter password. So we have to figure out what this password is. Now, this would be, if you're used to programming, this is going to be a challenge. But what we're going to do is now we're going to go the opposite way and reverse engineer this. And so what we'll start off with is this utility called hexdump. And let's take a look at this. And what you see here is this is the actual program. It's not the source code. This is where it finally ends up. This is a series of numbers. And so on the left side here, you'll see an offset. And then over here, this is the actual definition of the program. I mean, this is the ones and zeros that the program turns into when it's compiled. Now, it's not shown here as ones and zeros. It's actually shown as hexadecimal, but it's just shorthand for binary. Now, our goal is to try to parse and understand these numbers so that we can then extract the meaning of them. What's the code? What's the data? Things like that. So one of the first things that we're going to do is we're going to take these numbers and we're going to cross-reference them with a standard lookup table, the ASCII table, which I'm sure many of you already know about. So let me open the manual page for the ASCII table. And here we have the lookup table. So here is the hexadecimal column, like this. And then here are the characters that column aligns with. So for instance, 41 is capital A. Let's see down here, we have 5A is Z. So what we're going to do is we're going to take all the numbers of that program, and now we're going to cross-reference them with this table and see if anything comes out, anything intelligible. And that'll just be hexdump capital C, like that. All right. I don't see anything interesting yet. Let me scroll up a little bit. Okay, so here it looks like some actual text. And you can see here it says debug _str. And then over here are the numbers that represent those characters. So this is 2E, which I think that is actually a dot or a period. And then here's 64, 65, 62, and then that's DEB, like that. And then what we can do is we can start going through all this text and trying to understand what the binary is supposed to do. Now, this is very difficult and it's a little annoying because the text is like tightly wrapped up in this column. So what we're going to do is we're going to use a command that's called strings. That's the one listed back over here. We're going to use strings now, and strings is going to show us just the ASCII and not show us the numbers, because we don't really care about the numbers. We only really care about how they're parsed as ASCII. So let's run strings re1. That. And here, this is much easier to read. Let me make this a little larger. There we go. So now we're going to scroll through this, and we're going to see, is there anything hinted here? Is there any, maybe the password stored in here? It's kind of hard to tell. But let's see. We have some functions. Let's see. There's printf, string compare. That's probably where it compares our password there. And let's keep going up. And let's see. What do we got? Here. Oh, so we have enter password. And then we have something that says, you got it. Okay, so I haven't seen that string actually come out of the binary, but I did see enter password. But just above it, something is interesting, and it's weird. It's weirdly written, but it looks like it says, gotta start somewhere. And let me tell you, true story. All reverse engineers everywhere all started with hexdump and strings. Now, it's written in a way that like numbers are replaced or letters are replaced with numbers. It looks like it adheres to somebody's corporate password policy. So I'm just going to take a guess here, and I'm going to copy this. And now let's run the program again, and then let's record the password or paste the password in. Okay, you got it. Okay, so that worked. So now we learned something about hexdump and strings and the ASCII table, and so that's all good. So now what we're going to do is we're going to take this information and we're going to just put it into our Jupyter Notebook, starting off with recording the password, because I don't want to have to figure that out again. So let me scroll down a little bit here in our Jupyter Notebook, and under here it says solution. I'm going to execute. Let me just do ls. Okay, there's the binary. Now what I'm going to do is I'm going to do echo the password, and I'm going to pipe that into the binary. Okay. And there it says, enter password, you got it. Okay, so that's good. At least I recorded the password. But what I'd also like to do is just record what I did. And what I should also mention is that our trainings they're all recorded, and you just get to keep all the videos. So even if it's something or you don't take notes or what have you, you can always go back and you have the recordings. But I would say if you wanted to look up a command that you learned during class, you don't want to go through like 8 hours of video, right? You want to have your own personal notes here. And so what we're going to do is let's record some of those commands we learned. Let me put these side by side, a little easier up here. So some of the commands we learned, go into, well, actually, there we go. So hexdump-c, that was one of them. So I can execute that here and just record that command. Yeah. But it's a little, it's not formatted well just because it's Jupyter Notebook. So the zoom is a bit off. But I don't actually need the entire output. Maybe I want it, but I don't think I need the whole thing to remember the command anyways. So here's what I'm going to do. I'm going to just pipe this into another command and then just take like the first 10 lines. And then for me, that's good enough to just realize, okay, this is what this does. Now, in addition to hexdump, we're going to take a look at strings. So let's do strings re1.exe, and then I'll also pipe that into head and record the first 10 strings. Now, if I wanted to actually record the password, I could, I could just do a little bit more. Why don't I do 20, something like that? Whoops, that was the wrong one. That was hexdump. There we go. So I take the first 20 lines that we see, gotta start somewhere is there. And I think I have one other thing to show you for this exercise, which is what we use to record how we do things, which is, let me do a hexdump like this, and I'm going to pipe this to less, that way you can see it all on the screen. And I wanted to show you, and this is one of my favorite parts about Jupyter Notebooks here, is that what we can do is we can record, our workflow. And so like here's the password. It actually did show up in the hexdump. It was just hard to find. But here's one of my favorite parts about this training environment is I'm going to do a print screen, And this is like a third-party screenshot utility. And I'm going to do these. I'm going to highlight this. And then let me grab this square here, and I'll highlight password. Whoops. Make that a little thinner. Whoops, that's not what I wanted. I'm going to do that. I wanted that one. There we go. Let's do that. There we go. Okay, so we got enter password, and then I can put an arrow here and say something like, I think this is the password. So let's do that. Okay, now I'm going to save it. And so I save that screenshot. I'm going to just open the files here. And there's already in our Jupyter folder, which is on the desktop, it has the entire class. Everything's all in here. So here's our screenshots. And I'm just going to add this screenshot to the Jupyter Notebook. And it's just as simple as dragging and dropping it like that. And now, as part of my workflow, I have a screenshot of of how I did it, and part of my process of investigation. And as your investigations or your reverse engineering efforts get longer and longer, you'll need to sort of write down how you did things, and so you want to keep your commands. So the last thing I'll mention here is that beyond reverse engineering, we also teach many of the applications of reverse engineering. So here in this Jupyter Notebook, I also have exploitation. And exploitation is sort of the art and science of finding vulnerabilities in programs, which you can definitely do once you start reverse engineering. And then once you do find the vulnerabilities, how do you use those to gain control of a program? You've probably heard of like a lot of the famous vulnerabilities out there, the ones that all have like logos attached to them and things like that. So we teach people how to apply the reverse engineering skills to vulnerability discovery and exploitation. And in addition to that, we also do malware analysis. So the fundamentals of reverse engineering are applicable across many disciplines in cybersecurity. And so we teach all of those. So I think with that, let me sort of turn it back over here to Amber.
So that was a demo done by Jeremy Blackburn. He's one of our head trainers at BCI. And if after seeing that demo, you are curious, you're interested, you want to know more, well, we're going to give you the opportunity. Just come on by our booth, sign up for a 5-day class. It's completely free. And this is to motivate anyone out there who is familiar with forward engineering, reverse engineering, and exploitation and wants to know more, or someone who's like, hey, that might be fun. And it is. It's very fun. So thank you all for having us here today. We look forward to hearing from you for questions, and definitely look forward to seeing people sign up for the class. All right. Thank you.